Okay, we're going to finish chapter 1 today, definitely. And if we can, maybe we'll start a little bit of an introduction to chapter 2. But vectors is the last portion about dealing with physical quantity. So a recap of what we've done last week, right? We looked at how we represent physical quantities in unit, prefixes, and uncertainties. Okay, we learned to combine uncertainties using identities. Now we're going to segue a bit to talk about what happens if physical quantity has a direction. So for example, certain values have direction and also magnitude, forces, velocity, displacement. And in chapter 2, we will encounter velocity, displacement, all this stuff lah. All right. So we represent vectors sometimes using language. We'll do some questions later. Okay. Sometimes we use diagram and sometimes we use equation. But the equation part is maths, so we're going to focus predominantly on the first two. And then we look at how to combine two or more vectors. So this is one where we are asked to draw some vector triangles. So we're going to brush up on that before we talk about hardcore calculation. So let me pull up the notes first. As usual, you can find these questions in your Google Drive. Okay. All right, let's see. So besides the kind of addition question, sometimes the question can look like this. These are all just random vector drawings that we're practicing, okay? This is on page 11, May, June 15, paper 1-2, okay? So it says here, the arrow represents vector R. I'm just going to trace out the arrow on my tablet because I can, okay? And which diagram doesn't represent R as two perpendicular vectors? Let's see. Let's say now I have this vector, right? And then I have to figure out which of this possible combination, when I add them together, I will get R. All right. So let's look at A. A, I move upwards, and then I move to the right. So just by adjusting the vector diagram a bit, it is like you move to the right here, and then you move upwards. And then if I bring in R, let me change this to red. If I bring in R, R looks like the resultant here. You can see, right? This one can possibly be R. Okay. So again, it's by the double-headed arrow. And maybe during the exam, you will have to actually draw this on your own exam paper. All right, let's look at B. B has this one, which is also pointing up. Okay. And what we're going to do is we're going to move this here if you're more used to this option. So you move to the right and then you go slightly upwards. Let's see if R can fit. So, yep, it's a possibility, not going to lie. Okay, it looks like it's possible. So A and B is possible. Okay, so we're going to repeat again for C. So what you will do in the exam, because you can't do what I'm doing on a writing tablet, right? Use your ruler to try your best to transfer the arrow. Okay. So in both cases, right, when I transfer the arrow, or basically if you want to, you can build a parallelogram like this. Okay, this is just using the diagrams. So if I transfer the arrow this way, or I draw a parallelogram this way, I find that this resultant is still sort of in this direction. So A, B, and D can. Whereas for this one, it feels like the resultant is pointing slightly downwards, don't you think? Down in this direction. So this one is probably the answer C. Okay, so these are all just about drawings. What we're going to do is we're going to take one vector, add with another to get R. And this plus this looks like it can become R, just like for option B as well. Option B is too small for me to highlight. Option C cannot. Here plus here doesn't look like it would have R, because R must be pointing upwards. Okay, the answer is C. So vector drawings are oftentimes like this. But let us level up a bit And consider what we are doing here when we look at a diagram like option A, okay? So we're going to look at the second or the fourth option or skill that we're going to learn after combining vector. So let's go back here and label this as skill 1. Combine 2 or more vectors. And we're going to now look at skill 2 because sometimes we want to resolve or split. So I'm going to put split in bracket because it's not like the original term, to split vectors. Okay. So we're going to look at, let's say I have a vector pointing in this random direction. Let's say this is vector A. And this angle here is theta. Okay, theta to the horizontal. So I can split vector A into horizontal direction, very much like the diagram that we saw just now. Let's say this is vector X plus vertical direction, vector Y. So I will then say vector A is equal to vector X plus vector Y, if I write this in vector notation. Okay, but can I find the magnitude of X and the magnitude of Y? We always want horizontal and vertical because that introduces 90 degree into your vector triangle. And 90 degree is the best kind of triangle because we can use our known trigo identities. So for example, for this one, if I want to find magnitude of X, X is right beside of theta. Theta is here. X is right beside. So I'm going to use cos theta, okay? Cos theta would then be equal to side over hypotenuse A. So vector X is actually equal to A cos theta, the magnitude of X. Okay, so the magnitude of X, A cos theta. And then if I repeat the process again to find the magnitude of Y, you would probably be able to guess that I'm probably going to use sine theta because Y, this Y, is opposite of the angle. Okay, so your sine theta will now be opposite over hypotenuse, which is A. So Y will be equal to A sine theta. Okay, so oftentimes when you do question, the fluency that we hope that you can achieve is that when you look at the vector, immediately you can tell whether it's cos or sine. And this is done by observing the angle. Okay, so I'll make that notation for you here. For example, X is beside theta. That's why X is equal to A cos theta. Okay, and Y is across or opposite of theta. Opposite of theta. So Y is A sine theta, because sine is opposite. So generally speaking, they do expect you to be able to immediately write out the X and Y component. Okay, so an example of that, you can find it in page 17. And this is very important because if many physical quantities are vectors, you will always be dealing with vectors, and learning how to handle them is probably quite important. Right, I'm going to try an example now. Okay. You can find this in page 17. May, June 18, paper 1, 3, page 17. Okay. So again, the whole idea is whenever there's a vector, we can split into horizontal and vertical. And depending on which angle they gave us, if it's right beside the angle, you will use cos. If it's opposite the angle, you will use sine. So let's look at this question. Here we have a force F that is an angle theta to the horizontal, like this. What are the horizontal and vertical components of the force? You want to try first? So maybe you think, okay, this is moving to the right, so I definitely have a horizontal component that's moving to the right. And it's also going upwards, so I definitely have a horizontal component moving upwards. So this horizontal component is right beside the angle theta. So this is F cos theta. This is out. And now you are left with either F cos theta or F sine 90 minus theta. Which angle is 90 minus theta, you guys? This is 90, right? Right angle triangle. So this angle here is 90 minus theta, okay? Which means this vertical component can be seen as beside this one here. It's beside the angle 90 minus theta. So you can actually write this one as F cos 90 minus theta. So the answer is C. So sometimes they're sneaky like that. They will use different angle. Please don't go and memorize one must be cos, one must be sine. It really depends on what angles is given. It do be like that sometimes. Okay, let's look at another one. I make this smaller. Ah, yes. Right. All right, this one is May, June 19, paper 1-1. You will find this in page 19. So you will definitely expect one objective question. You just don't know how it will show up. So here, they draw the diagram differently. Huh? Notice that? So instead of having VH in this direction, and then VV in this direction, V is for vertical, H is for horizontal, and then when you combine, you get this one. V. They decided to draw this way. These two diagrams are equivalent, meaning they can be seen as the same thing. Right. What are expressions for the magnitude of V and the angle theta? So you're thinking to yourself, well, this is also a right angle triangle, and right angle triangles are, can use Pythagoras, right? So this is 90 degree. And if we use Pythagoras, V square is equal to VV square plus VH square. So if I want to find V, I will square root of this. Okay, so the -1 can throw away. All right, what about the angle theta? Obviously here we can use tangent because they use tangent. Opposite over hypotenuse. So not opposite over hypotenuse, opposite over side. That is tangent. So the opposite is VV because my angle is here. So opposite of the angle will be this one. And this is VV. Okay? VV divided by side, and side is VH. So we are looking for VV over VH. So the answer is B. So this kind of question is pretty okay. And of course, you're going to ask yourselves, why on earth do I need to split the vector into two? Like, what's the point? Like, it's all fun and nice, but what's the point? Okay. So here is an example of why we want to split. We're going to just carry on to page 20. Muka surat 20, page 20. Give me a sec. Right. This is June 19, paper 1-2. And this will be page 20. Two cables are attached to a bracket. All right. And then the force is 15 Newton and 6 Newton. They even helpfully marked out the vertical and horizontal direction. Nice. What are the magnitudes of the horizontal and vertical components of the resultant force? Okay. Resultant force means the sum of two forces. Or basically, we are trying to combine them. And they only want they want you to separate out the horizontal and the vertical. So in an ideal world, these two forces, this 15 and 6 Newton, is either one pointing in this direction and one pointing in this direction, then your resultant force will be 15 minus 6 because you're pointing in opposite direction, and you will get 9 Newton. Or maybe one will be pointing up and the other one is also pointing up. So this resultant force is 21 Newton. So when the vectors are parallel, we no problem, we can just add. So I'll just make a note here. Parallel vectors are the best. And parallel vectors is what we hope to find, because parallel vectors can be summed directly. That means I can add the magnitude direct. No need to think too much. Your life was this easy, right? So either 15 minus 6 or 15 plus 6. But now they're in this weird neither here nor there direction. So, but we have a tool to split them into horizontal x and vertical y, which is why we learn how to split them. Okay, so let's check out the 15 Newton first. Let's say I want to split this 15 Newton. And this 15 Newton will obviously have a horizontal component here. Okay, and this one will be 15, is right beside the angle. I'm just going to label here, okay? 15 cos 20. Okay, and this vector is also going to go up. So I can draw here, or I can also draw here. Most of the time, I prefer to draw here, because if I draw here, I may miss out too many arrows. I may accidentally miss out this arrow. But if I originate all the arrows from the same point, then I can find it. This is your triangle now. The same one that we have drawn here. So you need to know how to represent it in both ways. Now this one is the one that is opposite. It has no angle. So this will be 15 sine 20 degrees. Okay, we're going to repeat again for 6 Newton. But the 6 Newton here in the horizontal direction, this one is the one that has no angle, right? You see here. Here got no angle. Hiya. So if there's no angle, we will sign contract to borrow. So this will be 6 sine 40, or it's opposite the angle. All right. And then there is definitely one pointing down. This is right beside the angle, so this will be 6 cos 40. And of course, the arrow is here. So if it makes you feel better, you can obviously draw it this way. 15 followed by this and this. Just like down here, you have 6 followed by this and this. It's just that this is the 40 degree, okay? And this is the 20 degree. So first, the angle, the 20 degree is made with the horizontal, and the second one, the 40 degree is made with the vertical, okay? But right now, I have good news for you. After all this hard work, you will notice that, hey, these two are parallel, and parallel vectors can be summed directly. Oh, so this means the horizontal component, and because they are pointing in the same direction, I can take 15 cos 20 plus my 6 sine 40 degree. I can just add them up. All right, let me pull out my beautiful calculator. Ta-da. 15 cos 20 plus 6 sine 40. So I'll get 17.95 or 18.0. Here. What are you copying? 18.0. And then I can repeat the same process for the vertical component. Vertical component, these two are pointing in the opposite direction. 15 sine 20 is pointing upwards, but 6 cos 40 is pointing downwards. So this one must give it a nice fat negative sign. What's pointing downwards, ma? So negative 6 cos 40. All right, let's press our calculator. 15 sine 20 plus, no, plus, minus 6 cos 40. So 0.534. Okay. So your answer would be C. And then you might be thinking, okay, well, teacher, this means the force now. Let me crop the bracket again. This is an extension, not part of the question. But this means this force, right, is now simplified into this part. I have 18 Newton pointing to the right. And I have positive 0.5 Newton, which is a teeny tiny bit, 0.534 Newton. And then 18 Newton is pointing right. Remember, we love 90 degrees? Because if I want to find the resultant, which is the sum of these two vectors, so this is R, I can easily find this using Pythagoras. Okay. I don't know how to spell this name. Or this one will straight away be square root of 18 square plus 0.534 square. If it's needed, I can find easily. Okay. So this is why when we learn how to resolve vectors, because we want to bend the vector in the direction that we want, so that once they are parallel, we can do this kind of maths. We want parallel vectors. All right. Okay. Your turn. On the same page, which is page 20, there is another vector question that involves bolts. 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 So this will be page 20. By the way, ask me if you have questions, okay? Right, now we have an oil rig. It looks a lot like the bracket, right? Right. The angle change, the value change, the context change. Oil rig with 2 tugboats, but the steps will be the same. So in this one, they're asking us to come up with the total force acting on the rig due to the cable in the direction to the east. Oh, east. East. East is horizontal. And in case we all don't know where east is, they also very helpfully label east for you. All right, I'll give you a few minutes. Can you find what is the total force acting on the east? let me know if you're okay, or if you need a bit more guide. That is totally fine. Mm. You okay? How is it going? You okay? Do you need a bit of help? Let me know in the chat. No harm asking. Or do you need more time? Think of the horizontal. What value will you assign to it? And what would you do after you have split them into horizontal and vertical components? C. Okay, let's try. Let's just double check. Okay, so this one in the horizontal direction is right beside the angle. So you're going to go with 4 right beside. So that's cos 20. Okay, and then the 5 kilonewton, this one here is also right beside. This will be 5 for the 5 kilonewton cos 50 degrees. All right, this 20 is for the angle here. This 50 is for this angle here. And the magnitude of the vector will be in front. So in other words, when we want to find the total forces in the east direction or towards the horizontal, we will take 4 cos 20 plus 5 cos 50. So pressing this 5 cos 50, this will give me 6.97. So you're right, it is C. Well done. So it's not that hard. Just make sure it may be a bit intimidating at first because it's foreign. But yeah. Okay, so we're going to move on a bit to look at how questions from this chapter can look like in paper 2. All right, so paper 1 is this type plus the drawings that we have done previously. Then the one where we have combined drawings one like this to practice, okay? And then this one is almost identical. Okay, I'm gonna copy this and put at the side so you can compare them. They're all about the same. You pull here, you pull here. This one, you have 2 dogs. They're also pulling in opposite direction, like this. Okay. The only difference is the angle, right? Here, our angle is given in this side. This one, the angle gives horizontal. This one, the angle gives to vertical. Okay. So in this case, they want the resultant forward force. Forward force. Here. This one, they want to the east. Now, east is here. No? Hopefully, you can see the similarities, okay? You just repeat the same thing again. And the whole idea is for you to get that skill set. All right, we're going to try something a bit different. So let's look at paper 2. We just want to see how questions like this can look like in this paper. I'm going to check out page 10. Okay, again, let me know if you don't know where to find the note. Hopefully, you know by now. Or in the topical folder in Google Drive. Okay. So we're looking at page 10 now. These are quite straightforward. If you don't panic, just treat this like maths. Okay, and let me know if you need a bit more visuals, if you have trouble looking at or understanding the diagram. Talk to me if you don't understand, because I cannot read minds. I wish I can. That would be a superhuman skill if I can read minds. Okay, so here, it starts off by warming you up first. It says that there are 2 forces. This is P2, page 10. With magnitudes 5 and 12 Newton, acting from the same point on an object. Okay, I'm going to draw an object. So this is my object, and I'm boring, so I'm going to draw a box, okay? And they act on the same point, but in opposite direction. So maybe I have 5 Newton in this direction. Maybe I have 12 Newton all the way back in this direction. Oh. So what is the magnitude of the resultant force R? So of course you could say R is 5 minus 12, which is negative 7 Newton. But this negative here is to show that the direction is to the left. Direction is left. But we don't want the direction, we just want the magnitude. So magnitude means 7. And then you must put 0.0 because all your answers must be 2 significant figures. If you didn't write 2 significant figures, they can just choose to not give you marks 1, okay? So always write your answers in 2SF. So does it matter whether you take 5 minus 12 or 12 minus 5? No. The negative direction, negative sign merely shows a direction. And they only want the magnitude because vector got both magnitude and direction. They're only asking for the magnitude. So it's 7. Next one, right angle to each other. So for right angle to each other, this is my vector drawing. I have 5 Newton here. And let's say the 12, they say act on the same point. So here, 12 Newton. Where's the resultant? So you could build a parallelogram like this. Of course, you're pulling to the right and then you're pulling downwards, example. So this is the resultant. Teacher must pull like that, man. No, there are many possibilities. For all you know, you could have 12 Newton here and 5 Newton here also can. I don't know. It doesn't matter. Because these are all the same rectangle. The resultant here will all have the same value. Different direction, but same value, R. So to find this R, I will take 12 square plus 5 square and square root. But if you know your Pythagoras triplet, you will know that R here is 13. 5, 12, 13. Okay? So in other words, right, if I think about this, and let's say for example, I have an object like this scenario. So I have a box like this. And I have 2 forces. Let me start with 5 as the anchor. And I have 12 Newton, where this 12 Newton can be any theta. So that means this 12 Newton, I can rotate like the windscreen can rotate, windscreen wiper. Okay, that means this 12 Newton can be here, 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 many different directions. Okay, so if let's say I want to draw a graph of R being the resultant of 12 Newton and 5 against theta, what kind of graph will I get? Because this 5 and 12 Newton, I can keep changing the angle. Let's say I can rotate it upwards to 180 degrees from 0 degree. So if you think about 0 degree, 5 Newton is here and 12 Newton is here. They are the same direction, right? So 5 plus 12 is 17. So in this case, R is 12 plus 5, which is 17. So we're going to start with 17. Okay, let's say this unit is in Newton. And then as it rotates, eventually, theta will reach 90 degrees. And we already know what the value is for 90 degrees, right? Let's say 12 Newton is here, or maybe we anchor with 5. So 5 is here. And your 12 Newton, 90 degrees, so 12 will be pointing upwards. Now, this is 90. If this is 90, we already find the resultant, right? The resultant, I'm going to use orange. This is the resultant. And this resultant will be 13. So at 90 degrees, this one is going to be 13. And what happens when it's 180 degrees? 180 degree means that now your 5 Newton is here, but the 12 Newton is in the opposite direction. Okay, here to here is your 180 degree. So do we know our resultant? Yes, resultant will be -7 Newton. Or so we went from magnitude, not the direction, just the magnitude, from 17 to 13 to 7. So we're going to drop this one to 7. I guess I need to move my axis a bit. Make it a bit more, touch more accurate or to scale. So 17 dropped to 13 at 90 degrees. And then 13 will drop to 7. So 7 is actually almost halfway from 13. So maybe somewhere here. This is 7. So the magnitude actually decreases this way. I mean, it's a slightly increasing gradient. Because the drop here is -4 for the first 90 degree, and the drop here is -6 for the next 90 degree. So it's a curve of increasing gradient. Okay. So this one, they have asked you to sketch, ask people to sketch before in objective, like choose the right graph, which you can always put values into tests. But the funny thing here is, this means that when there's two vectors, I cannot just add them together. I cannot just say 12 plus 5 is 17, because 12 plus 5 is only 17 if they are parallel and the same direction. If they are opposite direction, it will be 7. And if for all the angles in between, it will be any values between 17 and 7. And we don't know. We need the angle. Okay? That's the whole idea of vectors. We are learning how to add them together. So for part B, now we have an object X rests on a smooth horizontal surface, and two horizontal forces act on X as shown. So this X, or this poor X, is being pushed in this direction by 18 Newton, and then being pulled in this direction by 55 Newton. Okay, obviously the length of the arrow is not drawn to scale. Okay, because 55 cannot be this long if 18 is this long. They look about the same length, so cannot. All right, so use the resolution of forces or a scale diagram to show the magnitude of the resultant force acting on X is 65 Newton. So basically, I need to sum up this 18 and 55. Okay, so there are a few ways to do it. You know, you could do what I did just now, which is build a parallelogram. So this is your scale diagram method. You can use your ruler and your compass or your projector and build a parallelogram. But before you build a parallelogram, you actually have to measure out the distance. Maybe this one you measure 5.5 cm, and maybe this one you measure 1.8 cm. And you better make sure this is 115 degrees. If it's printed out in the actual CIE paper, it'll be 115 degrees. If Miss Lee cropped like this and accidentally stretched during printing, it may not be 115 degrees. So scale drawing method works if you actually draw a diagram. But in this case, I'm not going to draw a diagram. I will resolve. Okay. So resolving vectors involves a few steps. Step 1, you do X, or you split the X and Y component. Okay, we do together. 55 Newton need to split or not? No, teacher, 55 is already X. I call this Fx. Okay. What about 18? 18 need to split, right? Because 18 is at this weird angle. So you're going to have to split 18. So think about 18. 18 is moving in this direction. So it is moving downwards. So there's definitely a vector pointing down because it's moving down. And it's also moving to the right. So there's definitely a vector pointing right. Can you see? These two will be the same as 18. Okay, now I leave it to you. Give you a few minutes. You tell me what is this fx? Because it's the horizontal direction. And what is this fy? Because it's the vertical direction. And I am going to refill my water. Type out fx and fy, please, Nicole and Yusi. Let me know. I'll be back after I refill my water. I am back. So, what's your x and y? You can give me a number. You can type out whether it's something cos something or something sine something. Let me know so I know that you are following, you're okay. Nothing concerns me more than whether you're okay or not. X is 18 sine 25. Okay, nice one. I like how you found the 25 degree. This angle here. 115 minus 90 is 25. So this is 25. Nicole, what about you? Are you okay? I know you're tired, but hang in there. Hang in there. So this one is 18. It's opposite the angle, sine 25. So I'm just going to take your 7.6 Newton, okay? And then Fy here would be 18 cos 25, and then this would be, I'll press my friend in case you, cos 25. Okay, this is 16.3. And here's what you can do to always double check. You can always take 7.6 square plus 16.3 square. And then you see this value, you go and square root. You should get close to 18. That's how you know you are sort of on the right track. Okay. So that's why this one, we can split, we can combine easily when it's 90 degrees. All right, so once we split, step 2, we will sum the components. And I will show step 2 as part of my working. Okay, so obviously my horizontal component will be equal to 55 plus your 7.6, which is 62.6 Newton. Okay, and the vertical component, I'm just going to call this Fx, and I'll call this Fy. Vertical component only got 16.3 because 55 Newton ain't got no vertical component. So now you have these two. In other words, if I draw a vector, I will have 62.6 in this direction. And then I move up by 16.3. So the resultant here, let's say this is R. R will now be equal to square root of 16.3 plus 62.6 squared. Again, using the Pythagoras. So we can definitely find R using this. Just. And then square root also. So this is 64.68 or 69. So approximately 65 Newton, which is shown. Okay. So the resolving vector one always can do, because no matter whether you got 1 vector, 2 vector, or 10 vector, you can just repeat the splitting of the vector for all vectors that is needed. So if you've got 10 vectors, then you split 10 vectors into x and y component, like do accounting like that, lor. Then you collect all the x, sum them together. Collect all the y, sum them together. And once you have x and y, combining x and y is easy because this is 90. All right. The angle between the resultant force and the 55 Newton. Okay, where is the 55 Newton? 55 Newton is horizontal. Right, this is the 55 Newton. So we're going to have to find the angle between R and the horizontal theta, which coincidentally, not coincidentally, which obviously is this theta. Okay. So like the objective question, to find theta, I will use tangent. Tangent theta is 16.3 over 62.6. So tangent theta, 16.3 over 62.6. Tangent inverse space. Okay, so what I have is 15 degree or 14.6 degree. That's all. Write out the tangent. So if you're wondering where the marks are, if the tangent is the correct ratio, you get 1 mark, C1, calculation 1. The angle is answer 1A1. Okay, and then for this one, we are using the resolution of forces method. So if I see 7.6 and 16.3, it means you resolve correctly, you get C1. 7.6 and 16.3. Or 18 sine 25, 18 cos 25. Okay, you get C1. Next one is when you add them together by I can see 62.6 Newton, and then I see the transfer into Pythagoras. This is another C1. Of course, the final answer won't have mark because the answer is given to you. All right. Okay, next. A third force. Got another force. A third force, 80 Newton, is now applied to X. Opposite direction to the resultant force. So our resultant force was this direction. There, this direction, R. And we calculated this R as 65 Newton. Now we apply 80 Newton in the opposite direction. So 80 Newton, opposite or means directly opposite this way. 80 Newton. This is the third force. So it says here, calculate the magnitude of the acceleration. So the reason why we obsess so much about resultant force is because we can equate this to MA most of the time. So FMA is not a new equation to you. And in this case, since we are applying this 80 Newton opposite, it will be parallel to R because opposite direction, like this. So from here, I am just going to take 65 minus 80, or 80 minus 65 is 2.7A. And you can find your A. Right? So 65 minus 80 is 15. 15 divided by 2.7 will give you 5.5. 5.6 meter per second square. Okay. So this one is 3 marks because if you subtract them, of course there's a negative here, but the negative here shows me the direction of acceleration is here. Because this is negative, this is positive. Okay. So remember, the sign is always given to show opposite direction. It's not a judgment on the value, it's just direction. We slap a negative there to show that it's opposite. All right, so 1 mark is when you subtract 65 and 80. The other mark is when you equate it to MA. And then this one is the final answer, A1. Okay. Vectors do be like that. So obviously you can tell we apply vectors later in chapter 2, in chapter 3. In fact, we will keep using vectors all the way until chapter 6. And then we take a short break and we start A2, we will see vectors again. So vectors is like very important now. It's like doing algebra and maths. Don't know how to do algebra, cannot do maths. Okay. Right, we're going to try one more slightly different question. This one is involving equilibrium. Okay, so I think trial by fire. We'll start. This is in page 12, 1-2. And because vectors have many applications into the other chapters, so there are not many past year questions that just ask vector alone. Normally, they will combine with other topics because of that. Okay, but here we can find this on page 12. Okay. So it says here a block of wood of 25 Newton is held stationary. So when I see the word stationary, right, I know that my resultant force is 0. It's not going to go anywhere. Or in your IGCSE word, they like to call it balance force. So all the forces are balanced and the object will not go anywhere. It's a bit like you and your brother is fighting for chocolate. You pull here 10 Newton, your brother pull here 10 Newton. Your mom tried to break up the fight, she pulled 20 Newton. Your dad tried to break up the fight, he pulled here 20 Newton. Everybody just cancels off, the chocolate stays there. Okay. So if I know that it is held stationary, it means that the sum of the x component is 0, and the sum of the y component is 0, and everybody is 0. My favorite number, 0. Okay, not related to the question. But here is my diagram. I look at all the angles. Okay, and what does the question want from us? Let me crop. So the question is saying, the tension in the string is T, and the slope pushes on the block with a force R. Okay, so this R is a normal reaction force. We will study the type of forces in chapter 4 later, but just take it for now that there is a force that's holding the box in place. There's a tension pulling the box upward, and then there's this weight pulling it downward. Either by scale drawing or by calculation, determine T. Find T in the string. Okay, so this is a bit different because previously we never really had to deal with unknowns. We just calculate stuff, all right? But let's see what tools we have. Remember that our tools are always, we can either use equation or we can draw diagram. Since we've been practicing equation so much, let's use equation, okay? And we sort of know that we're going to split everything into vertical and horizontal, right? But if you do so, this drawing or this diagram is going to look a bit scary. So for the R perspective, I will split in this direction, okay? Vertical and horizontal, like so. Okay, never mind. This is R cos 35, and this is R sine 35. Not very phased. I'm going to repeat the same thing for T, right? T will have one in this direction because T is pointing to the right, and T will also have another one pointing upwards. But teacher, I need an angle. I know. Of course, we need an angle. This baby is 90 degrees. So if this thing is 90 degrees, and you take 90 minus 35, I believe you will get 55 degrees. Okay? So which means this one up here is T, sine or cos, right beside the angle, cos 55. And this one here is T, sine 55. Ooh, things are getting quite complicated, but don't worry, we're done. Sum of the upward forces is this, and it must balance with 25. So the upward forces are cos 35, which I will not press calculator for now, plus T cos 55, my bad, is equal to 25. I can't solve the equation because I got two unknown. But I also know that the forces to the left must cancel with the forces to the right. Okay, so the second equation that I can form is R sine 35 is equal to T sine 55. And then remember, we just want to find T, so we substitute R, okay? R is T sine 55 over cos 35. Don't forget, all these sine 55, cos 35, all can press calculator one. So I can keep them, or I can, if I don't like to look at them, I can just press calculator. Okay, so I'm going to throw this one inside. I substitute equation 2 into equation 1. Sub 2 into 1. Now when I sub 2 into equation 1, this one will be T sine 55 over cos 35. This is my R. I substituted this into here, okay? Cos 35 is still there. Plus T cos 55 is equal to 25. So the cos 35 and cos 35 just cancels off. All right, and then they both have T, so I factorize the T, and I will have sine 55 plus cos 55 is 25. So here you can find T. So the X and Y component will never fail you, but it will occasionally bring you extra work like this, extra complication. And if you are not very comfortable with solving simultaneous equation, there'll be problems, or you may need a bit of training. but this is the most complicated way to solve this question. Of course, then you think, easier way, teacher. God, let me write the answer first. 17.95 Newton. God, of course, God. I don't do this way. I do this way because we've been training X and Y component. Okay. But then I think to myself, I already have 90 degree in my drawing. So I'm gonna draw on the drawing again. Okay, again, I throw this all in Google Drive if you need to refer to it later. Okay, don't worry too much about copying. Just try to follow along and ask questions if you have any. All right, so I think to myself, right, this thing is already 90. Can I choose to not bother about it? Can. As long as they're 90, you're okay. So the only thing that's not 90 degree is 25. So instead of splitting R and T, I can obviously split 25. What I'm looking for is just parallel, right? So 25 can be split in this way. And then if it makes you a bit happy, and it does make me happy, I'm going to take this one and put here. Okay. And if that's the case, I can quickly see that I can transfer the angle, and this is 35 degrees. So this is 25 right beside the angle, cos 35, and this is 25 sine 35. I can press calculator, but I'm a bit lazy. I don't want to. So what I know is this tension that's pointing upwards must balance with this 25 sine 35 that's pointing downwards. So I can just directly say natural T upwards, the slope will be equal to 25 sine 35. I better hope that it's the same answer if not I try. 25 sine 35. Is it the same? This one is 14.4 Newton. Okay, so let me double check. 25 to the sine. This is okay. That means there's a problem here. This is sine, this is cos. 90 minus 35. Need to double check everything that I calculated in my brain. This plus this is this. Yep. This is this. Okay. 55. Oh, I see the error now. You see sine 35? You see this one here? Why did sine 35 become cos 35? So this one is very error prone one, which I generally don't recommend. Or you press calculator lah. Let me fix the error. Sine 35 here. Okay. It's a transfer error. In the process of transferring, I don't know why my sine became cos. It happens. I was very tempted to cancel off, but looks like I can't. Don't worry, we can press calculator. So if you don't want to deal with this, you can always just press sine 55 divided by sine 35. No problem. Okay. So this one will be T times, I don't remember, 1.43 times cos 35. I just times cos 35 directly. 1.67, 1.17, sorry. So this is 1.17 plus T times cos 55. So you can always just convert if you don't want to repeat errors, 0.574. Okay, well, so I will have 25 divided by 1.17 plus 0.574. 14.3. The reason why I'm error prone is because I don't use this method a lot. So you see, even teachers, right, if we don't practice, we will make mistakes. It's very normal. So that's why it's important to know various methods to cross-check your answers and then to spot the mistake and change it. So if someone were to force my hand and ask me to do X and Y component, I can do it. I just have to do it slower. And then I will always cross-check with an alternative method or an alternative drawing because I just want T. So I'm not going to touch T. I will resolve 25. Okay, so your 25 is actually like this, followed by this, and then this. Okay, so this is the horizontal one, just 14.4. Of course, this is easier, like it's 10 times easier compared to solving a system of simultaneous equation like this. Okay. Pro tip is if you don't know what to do, X and Y component will always work, but it may take you a lot of damage. You have to do a lot of steps. Okay. There's another method. Wow, many methods. Yeah lah, many ways to get to Rome. So if let's say, for example, you go to your son and you go like, can I draw drawing? Can. And you need to know how to at least sketch the drawing for paper 1. So this is T, and I know it's supposed to bring with 0 resultant force. I'm also going to draw my 25 Newton. And then my R is 90 degrees to T. So my R is here. Okay. So this is my 25 Newton. This is my vector drawing. If you look at T, the alignment for T is here. Okay. If it makes you happier, means I can do this on a digital drawing. I'm going to draw T. Now T is like that. Length, I don't know, but this is T. Okay. Then I have MG. MG is pointing vertically downward like this. So this is MG. I can stretch it until I get R that is 90 degrees. So I'm going to keep stretching. Okay. So it doesn't have to be so big. It can be tiny a bit. Okay. And then I need this R to be 90 degrees. 90 degrees to T. See? This is R. So this R has to be here. But I can also stretch it. Change color. Okay, no. So I stretch this and I stretch this. Actually, I was stretching it in my brain until they meet, something like this. Okay. This is my vector drawing. 25 is going down. T is here. R is here. This one is always 90. See? We want to look for T, right? So all we need is an angle. The angle between R and 25 is 35 degrees. Okay, so if that is the case, you see when R is pointing upwards this way, and 25 is pointing downwards this way, R is pointing upwards, 25 pointing downwards, this is 35. So this one becomes 35. So this will also be 35. Okay, so check the direction of the arrow, especially if you are like what some of my students like to call themselves, a bit geometrically challenged. R is pointing upwards. So this is the line of R. Okay. 25 Newton is pointing downwards. This is the line of 25 Newton downwards. So this is the line of 25 Newton. And the angle between the blue and the pink is 35. We do alternate angle, inside here is 35. Can we find T? Yes, T is opposite, right? So I can say sine 35 degrees is T over 25. So T would be 25 sine 35. This sine, right beside opposite. Yeah, am I geometrically challenged? Sine 35. Yes, 25 sine 35. See? So 14.3. Now, if you ask me which one is easier, I think it depends on you. Do you like to draw? Drawing will look like this. Where should I put this? Okay, I want to put them side by side to compare, but then the screen will look too big. Nah. Do you like to draw? Do you prefer to, it's here. Do you like to draw? Do you prefer to resolve? Personally, I like resolving because it's cleaner. And I can resolve anybody I want as long as the result of the resolution is 90 degrees. Or I can always just draw the vector drawing. Okay. But in both cases, if it doesn't work, you can always default back to the, just undoing so that the diagram looks proper again. You can always default to the X and Y component. It's not wrong, it's just long. Method. This one. I don't recommend. You're going to take out too much of your time. So learn to tell which one to resolve. You go resolve these two is GG. But if you resolve 25, it's not that bad. Okay, because you want T, so you find someone that's parallel to T, they will be balanced. Has to be because it's zero resultant force. If not, you draw a cyclic triangle like this. Look at all three forces, this, and this, and try to put them together so you form a triangle. Cyclic triangle, vector drawing, whichever cyclic triangle that you have. This one shows us zero resultant force. So you can always draw a triangle. And then with the right angle triangle, it's just a matter of using sine or cosine. Hopefully that's not too scary. But let's look at something very recent. And by very recent, I mean ON21. Just to get a feel of the questions and if they change much, because there's no, what can they change? Not much, right? All right. Let's see. Okay. So we're only going to do the vector part, okay? Of course, the question has many parts, but we're just going to focus on the vector part, which is this one. Okay, now if you want a break, now it's time to take a break to rest the brains. And you won't have this question in your handout because it's fresh. It's ON21, paper 2-3, question 3. This question is not that complicated. It's mainly asking for resultant force. Okay, so we will resume at 10. I guess maybe I'll give you about 10-minute break. So we'll resume at 10:18 p.m. Tired ma? Take small breaks. So go and stretch, pat a pad, wash your face, and then if you want to, come back and determine the magnitude of the resultant velocity. Again, we have two arrows, but then they are pointing like this. Just now, our arrow was pointing. What was our arrow pointing again? It was on the inclined plane. Just now, our arrows were pointing like this. Just arrows. What to do when they are pointing this way? All right, go take a break. Come back in 10. Hey, let's check your answers, or let's do this together. So this one, it says that there is a remote control toy aircraft flying horizontal in the wind. Okay. Figure 3.1 shows the velocity vectors to scale, meaning if you actually take your ruler and measure, and we didn't stretch the diagram, the length here will correspond with 23, and the vertical length will correspond to 42. Right, the velocity of the aircraft in still air is 42 meters per second to the north. So this is when it's in still air. And the velocity of the wind is 23. Okay. In the direction 54 degrees east of south. So if you are wondering how to see this east of south, although they draw for you already, let's think of your north, south, east, west. You have north here, south is here, east is here, west is here. So east of south is, imagine you are standing on the south, and then you move 54 degrees towards the east. So if you move in this direction, starting from the south, this is what east of south means, 54 degrees east of south. Okay, in case they didn't draw for you lah. All right, calculate the magnitude of the resultant velocity of the aircraft. All right, so if I were to find the resultant of these two, meaning the aircraft is like this, but the wind blow the aircraft in this direction, where this is 54 degrees. Okay, so I'm just probably going to give them some value now. Maybe this is VA for velocity of aircraft, and maybe this is VW for velocity of the wind. Oops. Okay, right, so how to proceed? Okay, I'm just going to ask people, there's only 2 of you anyway. Would you like me to use the diagram? Which means I would probably be drawing some triangles that looks like this. Or do you want me to resolve? And because thankfully we already have somebody in the vertical component, and I just need to resolve the wind. Which one did you do? I'm curious, let me know. This diagram, you resolve. What's your method of choice? Where shall I start? Diagram or resolve? To find the resultant of these two. Let me know in the chat. You want the diagram? Resolve? Okay, can. We're going to resolve. And obviously, we don't touch the vertical one. We're going to touch the one that's at an angle, which is this one. So you have to point downwards, and then you have to point to the right. If you do alternate angles, this will be 54. Okay, so on one side here, you will have VW, or basically 23, okay? 23 sine 54 horizontally, and vertically downwards, you will have 23 cos 54 degrees. So I'm going to skip some steps, okay? The resultant will be equal to square root the velocity in the x component plus the velocity in the y component square. But x component, I only have 23 sine 54 squared. No more already. This is the only x component, this one. But vertical component, I got 2. I got this 42 pointing up, but I also have this 23 cos 54 pointing down. So I should minus them, okay? So plus 42 minus 23 cos 54 squared. You can just put everything, power everything inside. Or you can find separately, okay? Perfectly fine to take your time and do horizontal, vertical, combine. Okay. I just decided to skip because, you know, I don't want to do right more when I don't need to. All right, so 23 sine 54. And then we put a big bracket. Not bad. Then I'll square root later. Square plus bracket 42 minus 23 cos 54 square. You don't have to press everything together because you're scared make mistake. Then you slowly press one by one. Square root answer 34.0. Okay, this is the most minimalist way to solve lah. You split already, you take the x, you combine, you take the y, you combine. Then that's it, call it a day. Okay, don't forget to square it. But it's totally fine to find Vx, then find Vy, then put them together. Of course, I am compelled to show you the diagram method, because who knows, maybe you will slowly take to that method. After some convincing, I don't know. All right. So the diagram method, you look at this one. You have this thing going in this direction, and then you have this one going in this direction. Like that. So this arrow, right? I take this, and then I transfer over here. Cannot. It's the same arrow. And where's the resultant? Going up, then going down will be the same as here to here. This is not a cyclic triangle, this is the resultant. So I have this length, this vertical length is 42. I have this length is 23. I also happen to have this angle is 54. So to find the resultant velocity, let's say this is R for resultant, I can use the cosine rule. But because this is not maths, they won't give you the cosine rule. You will have to find the cosine rule yourself. So R square is equal to, okay, I repeat, cosine rule is A square is equal to B square plus C square minus 2BC cos theta. This is your triangle. This is A, this is B, this is C. The angle is between B and C. Okay, so if you know this, that will be great. You can just plug and use if you're familiar. If you are not, don't have to use. Resolve always will work. Okay. Let me press on the side in case you're copying. But yeah, resolve will always work. So I'm just showing you different method in case you see it in school and you need to interpret it in context. It's cos 54. All right. 42, 23 minus 2 BC cos 54. It's okay to have a preferred method. No harm. square, 23 square. Okay. Right, square root answer. I'll get the same thing after I do the whole cosine rule application, 34.0. You like more? Resolve will always work, so I prefer to resolve. Okay. So we're gonna just pop back into paper 1, just to remember this kind of resultant wind velocity question, and try the ones that do not give you diagrams. No diagram can be quite the headache. But before we start with no diagram, we just, since I'm already at this page, can look at page 24. We sort of discussed this, but not really. So this one is slightly different. So this one, you can find this in page 24. Here we have a force F, and P is the horizontal component of F. Meaning P is the one horizontal component of F, is part of F. P plus Fy, this is Fx. Okay. So because of this, your P happens to be F cos theta. And they ask you to show the variation of F cos theta. Cos theta graph will look like this. But in case you need some reason, let me pull that up for you. Or rather, you can, while the simulation is loading. It's gonna take some time for some reason. Let me close some tabs. Many tabs. There we go. So let's say you have a vector, okay, and then I'm just gonna, I don't know, I'll put a vector here. Just I can drag it in any orientation or any angle, okay, and then I can resolve in this way, this plus this, and if I adjust the angle, let's say the angle is 0, the horizontal component is maximum. If the angle is 90 degrees, so vertically upwards, the horizontal component is 0. Okay, so yeah, that's your vectors, which you can adjust and see. 0, maximum or horizontal, and then vertical, no body is horizontal. So in this case, 90 degree, the magnitude becomes 0. 0 degree, this P is equal to F. Okay. That's the nature of resolving the vectors. I'm going to look at one that requires a bit of I guess the term here is comprehension. Basically, is to write out the story. Because sometimes they can give you a drawing, but other times, what they'll do is they'll just tell you a story. Anyway, I'm just roughly going shopping for past year questions. So you can find this in just trying out different diagrams. Okay. May, June 16, paper 1-1. This is page 12. which vector diagram shows the resultant? Walao, so many arrows. Yes. So now these 3 arrows is not balanced, and hopefully it's obvious that it's not balanced because, you know, if I use to split this one, this tiny upward arrow ain't going to balance this large downward arrow. So which one is the resultant? What do you think? Stare at the diagram. Then you can let me know in the chat. Hey, possible? Let's see. I'm going to check in with all the vectors. This one is going down. This one is going down. But before that, we had a vector that is pointing to the right. And we sort of have it here. And after that, we have one that is pointing in this direction. Okay, lol, which is this one. Yeah, so you're right, it's B. Because the sum of these 3 arrows will cause a resultant in this direction. Well done, Nicole. Okay, last one for the day. I think. Depends on how long we need to solve this. So this is in page 16. This is what I mean by all word, no drawing. Hiya. So previously, most of the time they give you a drawing and then we operate from the drawing, right? So now this kind of question, they got no drawing. GG. But don't worry, just because there's no drawing doesn't mean you cannot do. I guess what we really need to do is to sketch out the arrows that they are not giving us. Okay. So I think I'll start off first with the bird. The bird can fly at a speed of 10 meters per second. Did they specify the direction? No. Speed here is a scalar. So there is no direction. This 10 meters per second can be anywhere. I don't know. Okay. But it's 10. I know the magnitude is 10. The wind blowing from the east. So from the east is an indication of direction. All right. So from the east meaning, you know, I've said before, this is north, this is east, this is south, this is west. If it's from the east, that means that the wind is blowing in this direction. So I have basically I have a 10 meters per second arrow that I don't know point to which direction, but I also have an 8 meters per second arrow that is pointing from the east, or in this case towards the west. So you definitely have an 8 meters per second view. The wind is blowing in this direction. Wind. Wind. Okay, don't know where the 10 is. GG. In which direction must the bird fly? So how should I angle my 10 meters per second in order to travel to a destination that is due north? Meaning I want to go north. As a bird, I want to fly north. But the wind is blowing me to the west from the east. So imagine all I want to go as a bird is from point A to point B. B is north of A. This is my objective as a bird. I just want to fly here in peace. But unfortunately, there is a wind. So if I go and fly north, but the wind pushed me to the west direction from the east, I end up flying in this direction, which is not helpful because the wind is blowing. So this is the direction that I want that I fly, but the wind pushed me here. So in the end, I go here. That's not what I want. My A is here, my B is supposed to be here. So how should I fly? I should fly slightly to this side to compensate the wind. Does that make sense? I need to compensate the wind. So if the wind is going to blow me to the left, I purposely move right a bit so that eventually the wind will push me to the left. Okay? So I'm just gonna, not that important. I want to go from here to here. So I think to myself, hey, this is my resultant. And all I have is this wind speed. So since this is the resultant, I'm just going to take this one and put here. Because this is where I should end up with, right? Okay. And in order to end up in point B, if let's say the wind is going to take me to the left, I will fly to the right this way. This is the speed of the bird. Okay, so the resultant will now be northward, A to B. We don't really need to find the speed of the bird. I mean, we know the speed of the bird, 10 meters per second. And it's just the direction that the bird must fly. So in that case, I have to find this theta. I guess I could use opposite over hypotenuse. That'll be sine, right? Sine theta is opposite over hypotenuse. So from here, I think your theta is 53 degrees. But let me double check. Sine inverse 53. Sine inverse 0.8. 53.1 degrees. Okay, but you don't cancel out first. I need to figure out how to assign the direction. So to assign the direction, I will need to draw a crosshair here and then mark out the direction of the bird. The bird is going to fly in this direction. And this is 53 degrees. Where was north? North was here. We stand at north, and then you have two decisions. You either turn here 53 degrees towards the east, or I guess you can turn here this direction. This is west. Okay, so this direction that we're talking about, this yellow one, or this highlighted yellow one, this one is 53 degrees east of north, which is what we want, this one. This angle, this blue angle here, just for practice, this one here is 53 degrees west because we turn to the west. You imagine you face north and then you turn 53 degrees to the east, or you face north and then you turn 53 degrees to the west. Turn. So this is west of north. North with the end. So this one you have to be able to draw. So what I did was, first, I drew what I know. I know there has to be a horizontal arrow. And then I drew what I wanted, because direction helps. Travel to a destination that is due north. Due north. This one. This is due north. Okay. You may know this for sure. The only thing left is B bird. And because the wind will always blow me to the left, I'm just going to fly slightly to the right to compensate. Okay, so east of north. And if you are good at visualizing, right, the west of north one can throw away already. I must fly east because the wind is blowing from east. So I have to fly east. And then now I have left 37 and 53 degrees, which is easier to find the value. Okay, so this kind of thing have to draw. So similar practice or questions like this, you can definitely find in your paper 2. Okay, so I'll just write down one here that you can try, similar. So I think, as tired as you are, to make these sessions worth your money, because I think you're paying good money, right? 2%. Okay, and I also want you to learn take away something back. So you should try to spend at least an hour or so looking back at what we've done and then asking questions if you have any. This is page 5. So the water velocity. Do this. Basically, you do everything in page 5. If page 5 is okay, then you're okay already. Question 1C. Also page 5. This one is about the boat. And this is just a random object. B. Not sure what B is. B for ball. B for potato. Okay, I think it's good enough. If you can do these two, you're okay. It's similar to this one. But these two, they give you drawing, which is always a welcome thing. When they give us drawing, it's very nice one. Okay. So you spend some time, you do these two, you understand, then you're okay already with vectors, generally speaking. Okay. So similar questions are these two. So next week, we can already start chapter 2, right? So just a quick reminder, it is totally fine to disturb me any time during the week. Okay. So you just need to go here and bug me. Okay. Students bug me one you see this one. Okay, so it's totally fine, just bug me. Okay. Then if you want a review, let's say for example today you're very tired, you feel that your learning is like, let's say 60%, and you want to like top up, you go to the library and resource, you can click on this website. Okay, this is basically a place where I dump all the things. So generally speaking, my colleague and I, we believe that if you really want to learn, things should be available to you. And if you need a bit more help, you want to converse with me, it should be available to you. But talk to me because I don't know what's on your mind. All right. So you can go to these YouTube online classes. Okay, and then you see everything is here. What you're going to do is just go to the AS Physics topic. What we're doing, chapter 1, right? So ignore the archive. This is chapter 1. So full playlist is here. It's either me or my colleague, and we use the same notes. We essentially purposely record in such a way where there's little difference between me and her. We teach the same stuff, slightly different examples, slightly different delivery. So this one all we go into in depth, and it allows you to rewind. So if you watch a live lesson, and even if I give you the recording of today's lesson, there's always going to be a lot of pause, a lot of wait. I drink water. I go and screenshot. It's all not here. Okay, we will cover examples. But if let's say you want to see how to do a scale drawing, this is me doing a scale drawing in a top-down view. Okay, so you can also try out. You can just, oh, Miss Lee got do this question. Pause. You go do first. Then you come back and you see me do. Okay. So I actually draw with the arrow. Okay, it's me. It's the same person. Okay, same person, different time. Okay. So not plugging it, but just showing you that this is something that I will not be able to deliver in a live class because I will have to adjust my camera all over again. All right, so you can learn how to draw a scale drawing by this. Or anytime lah, like, oh, when teacher talking about accuracy, I fell asleep. Totally fine. Nah. Go watch. Okay, maybe just slightly different human, but the idea is the same. All right, so we are done with this already. I talk about scale drawing method, resolving method, which is both that we have covered today. All right, so I just play around now. This one is the notice board. Everything is here. Okay, and then got other physics YouTube channel if you have time. But I understand that you are tired, so this is how you can minimize your amount of time by maximize the amount of things that you can get back. Okay, so only the 2 questions. So later on, where to find your notes? Okay, so reminder, you can click here or click here. Okay, talk to me if you have questions. You can always just, and then you can be like these students. You can just send your work. There's only 2 of you, so I don't think I need to create one individually for you. But you can just throw your work here if you want me to look at or double check your drawings. Totally fine. So use me as more than just a figurehead, someone to talk to, someone to clarify your doubts. Be a bit more active in your thinking. That will be the best way we can make use of our time together. Okay. All right, so next week, we're going to start with 2. And for chapter 2, remember all the skills that we learned, writing physical quantities, dealing with vectors. Chapter 2, we will begin using the skills that we have. So I will throw this into Google Drive. Let me know if you have any questions throughout the week. Stay sane, okay? Go rest. I'm going to stop recording.